.NET programs consist of code, lots of it, but all of it's contained in types, which is what I'm going to talk about in this video. And if you're enjoying the content, please leave a like and subscribe to the channel. There are two general kinds of types, value types and reference types. Value types are things like booleans, characters, numbers, enums, tuples, and structs, and their memory is located in the current stack frame. They also inherit from value type. Reference types are things like classes, records, interfaces, arrays, and delegates, and their memory is located in the heap, which is dynamically allocated. It's good to know that unlike the character type, strings are reference types. In practical terms, the difference between value types and reference types is that when you pass it to a function or assign it to a variable, value types make a copy of the value, whereas reference types only hold a reference to the memory location. Interestingly, all types have a common base type called object. This means that you can assign any value to an object type. If you assign a value to an object type, then it's automatically made into a reference type first by copying it into memory. This is called boxing. Conversely, casting it back to a value type extracts a copy of the value. This is called unboxing. Let's talk about each of these types in more detail. Classes. Classes are the main type you'll use when writing C#. You can think of classes as being a blueprint for things. Importantly, these things have their own identity because they are reference types and usually contain their own state and their own methods. They can also define additional types. For example, we could define a ball class that knows its color and has a method to make it bounce. There's only one definition of the class, but we can make as many instances as we need, each with a different color, by invoking the constructor with a new keyword. The constructor, by the way, is a method that's called when the instance is created to perform any initialization and has the same name as the class. When we call the bounce method, the class returns to us how many times it has bounced. The count of bounces is usually private to the class, meaning that it's not accessible to anything outside of the class. This is called encapsulation, and is an important principle that helps to write good quality programs. Another interesting thing about classes is that they can be related via something called inheritance. A class can inherit from another class and also multiple interfaces. Take for example three classes: cat, dog, animal. Animal is the common base class of the other two. Cat and dog are derived classes. We also sometimes call them subclasses. You'll notice that the base class is marked abstract. This isn't mandatory, but is sometimes appropriate when we wish to prevent creation of a class because it's conceptually abstract. When we talk about inheritance hierarchies like these, we talk about base classes being generalizations of a concept and derived classes being specializations. We can add methods to any of the classes. Methods that aren't marked private can be shared by derived classes, as if they were part of the class's definition. Methods marked as virtual can be overridden by derived classes. We can also mark methods as abstract, which forces non-abstract derived classes to provide an override. Let's do this now by customizing how each animal makes a sound. You can see that the caller of the makeSound method doesn't know the kind of animal. Each instance has autonomy and will do what is appropriate to it. In addition to constructors and methods, you can add fields, which are local storage in the instance, and properties, which are accessed like fields, but are actually a pair of methods called getter and setter. Let's see how this works. We can add a field for the animal's name in the base class. It's considered best practice to make fields private. By convention, private fields start with an underscore. To make the value accessible, we add a property with a get part and a set part. In the getter, we just return the value of the field. In the setter, there is an additional value available called value, which we can use to read the value passed. We assign this to the field. Now we can name our animals. But what would be better is if we can ensure that each animal gets a name when it's created. So we add a constructor with a name parameter to each class. For derived classes, we must call the base class's constructor before we enter the derived constructor using base. Collectively, all the fields and methods are called members. Structs. Structs are value types and can hold state. They can define other types too and can inherit from interfaces, although they are boxed when cast to an interface. In fact, they are a lot like classes, except that because they're value types, values are copied when passed or assigned, meaning changes aren't shared. Another curious thing about structs is that because they are values, even if they have a constructor, we can't guarantee that it's called. so be careful that you initialize your structs. Structs are great when performance is critical because they don't consume time for allocation or deallocation like reference types. Here's an example of a simple structure for holding a coordinate called point. It has a constructor that takes x and y and corresponding read-write properties. Alternatively, instead of passing parameters to a constructor for both structs and classes, you can replace setters with initializers. Then you can set the properties explicitly during construction. There are other nuances to structs that I'll cover in more detail in another video. Interfaces. Interfaces behave like reference types, but they can't hold state or be created. They can define other types though, and can inherit from other interfaces. Interfaces specify a contract. That is, when a type implements an interface, it must define any of the members that don't have a default implementation. Here's an example of creating an interface for our animal class. It defines a name property and makeSound method, but no implementation. To implement the interface, we use the inheritance syntax. Importantly, implemented interfaces must follow the base class, if there is one. Let's add another method to the interface with the default implementation. We don't need to implement this method in our classes because of the default implementation. One thing to note, however, is that the interface is a separate type from the class. That is, any members implemented are often done so implicitly. It's possible to implement a member explicitly, which means it's not part of the class's contract. Here's an example of that. See how we can't call the interface method on the class-typed instance? Importantly, interfaces are treated as reference types. This means that when a struct is assigned to its interface type, it is copied to main memory. Here's a demonstration. I'll define a struct and an interface that have a number property. When I assign the struct to the interface type and change the value, the original value doesn't change. But when I assign the interface type to another interface type local variable, I see the shared value. Records. Records are a relatively new type in C# that aims to simplify creating types that mainly hold properties. They can be defined as a reference type or value type. When you define a constructor, C# automatically creates properties and other things for you. However, even though they are like classes, when it comes to inheritance, records and classes can only inherit from their own kind. I'll cover records in more detail in another video. Enums. Short for enumeration, an enum is a type that defines an increasing sequence of named values. These are value types and are based on integers by default, although you can change that to any other integral type. Here's an enumeration for the days of the week. By default, the values start from 0, but you can change the value at any stage and the enumeration will always start from there. Enumerations are often used for bit flags, where each value is a power of 2. Here's an example of that. Note the use of the flags attribute, which makes the values easier to use. And if you're using bit values, calculating them can be simplified by using the shift operator. You can even combine flags together. Tuples. Tuples are value types and are actually syntactic sugar for the value tuple struct. These allow you to conveniently combine together a small number of values with different types. By default, the values are numbered items, but you can provide names, which makes them easier to use. Note that the names are only a convenience, and it's possible to assign the tuple to a tuple type with different names. The item position is king. I'll delve into more detail about tuples in another video. Arrays. Arrays are reference types, hold values of the same type, and come in two forms. There are arrays that have one or more dimensions, and there are arrays of arrays, also called jagged arrays. To define an array type, you append square brackets to the underlying type of the array. Here's an array of integers. To create an array, you must call new either with the size of the array or a list of items in curly brackets. If you need a multi-dimensional array, the type has additional commas and the initializer has the size of each dimension or each grouping in curly brackets. Jagged arrays are defined differently. For each layer, you append more square brackets. You can also make each layer multi-dimensional. Because all the arrays are independent references, you must create each one individually, as in this example. Delegates. Delegates are references to methods, and just like methods, they can be invoked. A delegate instance holds two pieces of information, the method to call and the object on which to call it. A common use of delegates is for events. An event is shorthand syntax for a private field and a special kind of property that has an adder and a remover. Events are used to add listeners that are called when the underlying event is raised, that is, when the delegate is invoked. Here's an example that demonstrates a simple callback. Delegates are types, and you can define your own. To do this, you define the return type and the signature, that is, the parameter names and types. To use your delegate, you can instantiate the delegate explicitly with a new keyword, passing the target method. There's also a newer syntax which allows you to just pass the method. Under the hood, the C# compiler writes the full syntax for you. So to recap, .NET has value types and reference types spread over classes, structs, interfaces, records, enumerations, tuples, arrays, and delegates. And that's all for this video on types. Be sure to check out my other videos for more details about each of these types. And if you enjoyed the content, please leave a like and subscribe, which will greatly help the channel. Thanks for watching.